How things move. Measurement of time. Time may be defined as the gap or the interval between two events. The standard unit of time is seconds. The larger units of time are minute, hour, day, month, and year. We know that the Earth rotates about its axis and also revolves around the Sun. The time taken by the Earth to complete one rotation about its axis is called a day. The time taken by the Earth to revolve once around the Sun is called a year. Measuring time. Common time measuring devices are clocks and watches. In the laboratory, we are required to measure intervals of time for which stopwatches and stop clocks are most suitable. To measure short time intervals, we use stopwatches. For example, time taken by an athlete to complete a race can be measured by a stopwatch. With the help of a stopwatch, we can usually find the time to an accuracy of 1/10 of a second. Stopwatches and clocks can be stopped and started at will. Reading a 24-hour clock. The time given by a 24-hour clock is very useful for train schedules to avoid any confusion to passengers. In this clock, the same time is not repeated and no AM or PM is used. The time schedule is as shown above. In a 24-hour clock, 8:30 means 8:30 AM, morning. 16:30 means 4:30 PM, evening. The timings from the 24-hour clock can easily be calculated as shown. Imagine that you are traveling in a moving train. There are many other passengers in your compartment. Is there any change in your position with respect to another passenger sitting by your side, even though you are moving with the train? Look at the nearby trees, lampposts, houses, people, and animals outside. It looks as if the trees, houses, and lampposts are passing by you at a great speed. But houses and trees do not move. It is actually you who is moving with the moving train. Uniform and non-uniform motion. If a body covers equal distances in equal intervals of time, however small the interval may be, then the motion is said to be uniform. For example, if a car travels 80 kilometers every hour, 40 kilometers every half an hour, 20 kilometers every quarter of an hour, and so on, the motion of the car is said to be uniform. If a body covers unequal distances in equal intervals of time, then its motion is termed as non-uniform. Speed. An object is said to be moving when it is changing its position continuously with respect to its surrounding objects. Suppose we observe the motion of a car and a bicycle on the road. It is noted that during the same time interval, the car is able to go much farther than the bicycle. This amounts to saying that the car moves faster than the bicycle. Thus, the distances covered by different objects in a given time, generally taken as 1 second, can be used to compare their motions. Speed quality. In general, the physical quantity that measures the distance traveled per unit time is called speed. Thus, the distance covered in 1 second gives us an idea as to how fast the car is moving as compared to that of the bicycle. Speed is equal to distance covered by time taken. The standard unit of distance is meters, and that of time is seconds. The SI unit of speed is meters bar second. For average speed, the formula is average speed is equal to total distance covered divided by total time taken. Uniform speed. A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time, however small the time intervals may be. Suppose a car runs at a speed of 36 kilometers per hour. The speed of the car will be uniform only if it covers 18 kilometers every half hour, 9 kilometers every 15 minutes, 3 kilometers every 5 minutes, 300 meters every 30 seconds, 1 meter every tenth of a second, and so on. Thus, the car has uniform speed only if it covers equal distance in the smallest possible equal intervals of time. Variable speed. A body is said to be moving with variable speed if it covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, however small the time intervals may be. Scalar and vector quantities. Scalar quantities are those physical quantities which possess the magnitude only, for example, mass, length, and speed, etc. Vector quantities are those physical quantities which possess the magnitude as well as the direction, for example, weight, force, velocity, momentum, etc. Velocity. The velocity of a moving body is the rate of change of position of the body with time in a particular direction. Uniform velocity. A body is said to be moving with uniform velocity when it moves without change in direction and covers equal distances in equal intervals of time, however small the time intervals may be. A body moving along a straight line with uniform speed is an example of a body having uniform velocity. Variable velocity. Since velocity has both magnitude and direction, it is said to be variable if either its speed is changing or its direction of motion is changing or both its speed and direction are changing. The velocity of a body moving along a circular track and covering equal distances in equal intervals of time is variable as the direction of motion of the body changes at each point of its track, though the speed of the body does not change. The velocity of a body moving along any curved path and covering unequal distances in equal intervals of time is variable as both the speed and direction of motion of the body are changing. Unit of velocity are the same as that of speed. Volume of irregular solids. To measure the volume of a solid of irregular shape by a measuring jar, place a measuring cylinder on a table. Pour water into it. Read the volume of water. Take a stone and tie it to a string. Lower it slowly into the cylinder till it is completely immersed in the water as shown in the figure. Take care that the stone does not touch the sides or bottom of the cylinder. You will see that the water level rises. Note the water level again. The difference in the two readings of water surfaces gives us the volume of water displaced by the stone. This is equal to the volume of the stone. To measure the volume of a stone by using an overflow can. Place an overflow can on a table. Fill it with water to the level of the spout. Immerse the stone in the can as shown in figure. Some water collected in the can overflows and is collected in the measuring jar. The volume of the water that overflows is the volume of the stone. Density. Density in the substance is its mass per unit volume. The density of a substance is found by dividing its mass by its volume. Density is equal to mass divided by volume, or D is equal to M by V, where D is density, M is mass, and V is volume of the substance. Hydrometer. The density of a liquid can be determined with a hydrometer. The hydrometer is placed in the given liquid and allowed to sink. The depth to which it sinks indicates its density. Determination of density of a solid. The density of a regularly shaped solid is determined by measuring the object's mass, calculating its volume and dividing the mass by the volume. The volume can be determined by submerging the object in water. The volume of the object is equal to the volume of the water that overflows. When this method is used for a solid that floats, we attach a sinker to the object to submerge it in water. The volume of the sinker is then subtracted from the total volume of water displaced to find the volume of the solid. This is shown in the figure. Example. A car travels the distance between Delhi and Karnal in 3 hours. If the distance between the two towns is 120 kilometers, what is the average speed of the car? Solution. Average speed is equal to total distance covered divided by total time taken. Given. Total distance covered is equal to 120 kilometers. Time taken is equal to 3 hours. Average speed 120 kilometers divided by 3 hours is equal to 40 kilometers per hour. Example. A boy cycles down from his house to his school at a speed of 18 kilometers per hour and reaches there in 20 minutes. How far is the school from his house? Solution. Speed is equal to distance traveled divided by time taken. Given. Speed is equal to 18 kilometers per hour. Time is equal to 20 minutes is equal to 20 by 60 hours, which is equal to 1 by 3 hour. Distance traveled is equal to 18 into 1 by 3 is equal to 6 kilometers.